All right, hello once again, Jeff Scott of Rankin Technical College. We've been going over the online PDF AppInventor2, Create Your Own Android Apps by Wolber, Abelson, Spertus, and Looney. We're now up to Chapter 20 of 24, Repeating Blocks. And again, computers are good at repeating things. In this chapter, you learn how to program repetition with special repeat blocks rather than copying stuff over and over again. All right. We've talked before how you define an app's behavior using a set of event handlers, events and functions that are executed in response to either a user action, time, or something else. Repeat blocks are another way, as they mention here, in which an app behaves in a nonlinear fashion. Repeat blocks allow you to repeat one or more lines of code over and over again. As most programming languages do, AppInventor provides a number of repeat blocks, including for each and while. All right. The while block is more general than the for each. It says while some Boolean condition is true, do one or more lines of code. After you've done those one or more lines of code, come back in and look and see whether or not the condition has become false. If it has, you're done. If it has not, you keep going. So back in Chapter 18, we looked very simply at a little bit of code that randomly called a number in a list. All right, it says a different strategy would be to send a thinking of you text to all friends and see who responds first. And here's one way of doing it. Now, this isn't bad, but you're repeating basically the same text every single time. Rather than these 1, 2, 3, 4, 5, 6 lines of code, which are basically the same except for the number, they're the same every time, it would be nice to write one routine and pass to that routine the phone number. I mean, imagine if you had 100 friends. Now there's 200 lines of code that are basically the same. So this is brute force, and as mentioned here, the brute force way of doing it is okay, especially if you only have just a few things that a few friends in this example. But the for each would provide a much better solution. All right? There you go. The other thing that the for each does is, you're not showing as much raw data as you did before. This is a much cleaner way of doing it. As mentioned, underneath the figure, okay, the author says here that it says you can read this code as for each item or phone number in the list, set the phone number to the item and send out the text message. All right. At the top of the for each block, you specify the list you're going to process. The block has a placeholder variable that you use along with for each. By default, it's named item, but you can rename it if you'd like. So, looking at loops. All right. The thing about loops is they allow you to write less code. You also write code that will run faster because there's less of it, and you write code that is actually more natural. All right. And it's also more maintainable. Okay, so as the author mentions right here, the for each is a good solution, the while is a good solution as opposed to using brute force. All right. From a programmer's perspective, the author says the for each would be much more maintainable and can be used even if the phone list is entered dynamically. Another very good point. Maintainable software, they mention here, is software that can be changed easily without introducing bugs. What ends up happening, and I've used this terminology before, if you think about what the user sees, all right, what the user sees on screen is oftentimes referred to as a GUI, or a graphical user interface. The key word there is interface. All right. The code that I should say the interface is what you use in your component designer. So that's your interface. The code that you use to make something happen in your blocks designer, that's your implementation. So you end up writing much cleaner implementations when you use loops. The end user probably will have no idea whether you're using a loop or not using a loop. And do they care? They would only care if it was slower to do one as opposed to the other. And I've given examples like this to my students before, but if you look at this, if I come through here and say, okay, here's a calculator, and I want to put in the number 369, and I want the square root. There it is. Now, my interface to this when I started was this. That's my interface. I know that I have to press 369, and the API says if I want an interface, I've got to press this button. I don't know what the implementation is that makes that 369 and pressing that button make this come out. I don't care. I just care that the answer is correct. All right, so why am I making such a big thing of this? Well, quite often, what happens with programmers is as time goes on, they figure out a better, faster, quicker, easier, whatever way of doing something. As long as you don't change the interface, if somebody came through here and figured out a brand new way to do square roots, so the implementation was different, as long as I still press that button, I don't care. I might care if I get my answer a lot faster, all right? But other than that, I probably don't care one way or the other. All right, using for each to display a list. We've kind of beat this one to death already. Remember too that when you're using for each to display a list, that it's quite possible that you can do some formatting, such as what's done right there, so that things all show on, so that each one would show on its own line as opposed to having everything run together. And they trace this, but again, feel free, of course, as always, to look at this, but ideally it's just going to make sense. Again, one of the things I appreciate probably about this language is the fact that it is as intuitive as it is. All right. The last block that we'll talk about in here is the while do. Again, it's more complicated than the for each. It's more general. It says, as mentioned there, repeat something as long as the test evaluates to true. So as long as the test evaluates to true, do what's inside of the block. When you get to the bottom of the block, check it and make sure. Now is the test false. If it's false, you fall out. Otherwise, you keep going. If you set it up to run where it never ends, that's an infinite loop. There are certain applications where you may want that to happen. And a while do loop would be very good for something like that. And they give an example of it, but again, they give an example and the author says, what did these blocks do? They performed one of the most fundamental operations, counting numbers. So you can set up a loop to do virtually anything that you want repeated. Again, computers are good at repeating the same functions over and over. This chapter explored two of App Inventor's repeat blocks, the for each and the more general while do. Okay? When we come back in the next chapter, we're going to go into chapter 21, which is defining procedures. So we'll be back with that chapter very shortly.